Hello, let's continue our Sudoku adventure with 1K Adventures by Riffclown. So this continues our 1000 Adventures celebration, which will happen until we run out of celebration puzzles from the setters. I even told them, if you want to make more and sneak them in, go ahead, because there's plenty to feature, so there's time to actually create and test them. All right, so this one is by Riffclown, and it's inspired not by a single puzzle, but the entirety of the series. Riffclown loves to do these kind of big celebratory ones. So let's go over the rules. We have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these Renban lines in the grid. Some of this is like making this look like a 1. This isn't anything special. It's just cosmetic. So this is just a line like this. You can think of it as a straight line down the center. But the way Renban lines work is they contain a consecutive set of non-repeating digits in any order. So what are consecutive digits? Like 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6, right? You just need a consecutive string of digits, but then you can mix it up as long as the line contains only that consecutive set. So this is a 4-length line. So maybe it's got 2, 3, 4, 5 on it. And so we could do 2, 3, 4, 5, like mix it up. That would be a valid way to fill this if you ignore all the other clues in the grid, obviously. Because there's only one solution to the puzzle. But what we can't do is like here we'd have 2, 3, 4, 6. 2, 3, 4, 6 is not a consecutive string of digits, so that wouldn't be allowed. And we also have black dots in the grid. These are your standard crop key black dots. So digits separated by a dot have a 1 to 2 ratio. That means that one of them is exactly double the other. So if this was a 2, this could be a 1, because 2 is exactly double 1. Or this could be a 4, because 4 is exactly double 2. Now, with crop key and a few other constraints, we always say not all of them are given. Not all of them are necessarily given. This means that we're not trying to apply anything about the rest of the puzzle, about any of the other cells. If there's a 2, 4 here in the solution and there isn't a black dot, that's actually perfectly fine. We haven't given you every single possible black dot. We've just given you some of them. And we also use the word necessarily because there's always the question, if we say not all dots are given, then that technically implies that there is somewhere we could have given a dot and we didn't. We're not trying to apply anything about that, just these dots touch these cells and one of them's double the other. That's all you can glean from that. Anyway, that is it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so we have I'm going to do the longest ones first. We have a 5-length Renban here. And this is typical Riffclown geometry. He loves to add geometry, especially to intro his puzzles. And so if you think about it, we can just use the fact that digits don't repeat on Renbans to help us out a little bit here. Because whatever this digit is here, it doesn't repeat in its box, and it also doesn't repeat on its Renban. And so there's only one place in the row green can go, and it is right here. And since we know that whatever digit goes here that we're calling green also exists in this row, it must be this digit here. Now there's another thing we know, which is that this is going to be either 1, 2, 3, 4, 5 or 2, 3, 4, 5, 6. A really nice way to think about that is it is missing a 1 or missing a 6. It has every other digit on it. Now that 1 or 6 that it's missing, where does that go in this row? Because we know it's not where green is, because green is on the Renban. So that can't be the 1, 6 that's missing, because if it was missing, it wouldn't be on the Renban. And so that missing digit goes exactly right here. This is a 1 or a 6. And that means that if this is a 1, this has to be a 2, because the only thing we do is double 1. And if this is a 6, then the only thing we can do is have it to 3 to fulfill the black dot. That makes this a 2 or a 3. Now, this is a 4-cell Renban. Let's talk about that. We can think about what is it missing. And you can think about, let's take 1 to 6 and let's take either from one of the extremes. Let's take off either the 1 or the 6. So that would make it 5 length. And then we can take off, like, let's say we took off the 1, then we can take off the 2 or the 6. And so we end up missing, the only things we can be missing are either a 1, 2, a 1, 6, or a 5, 6, right? So if I've got 1, 2, 3, 4, then that's missing the 5, 6. If I've got 2, 3, 4, 5, then that's missing the 1, 6. And if I've got 3, 4, 5, 6, it's missing the 1, 2. So we're lopping off. I'm not solving the puzzle here. I'm just demonstrating these. We're lopping off the end 2 digits from the end. And the only way to do that is lopping off 5, 6, 1, 6, or 2, 6. Now we know that this isn't on the Renban because it shares a column. So notice we can't lop off the 3. So it actually must be the 2. That makes this a 1. We don't need it to be green anymore because we know it's a 2. Now, this black dot here calls out to me because, first of all, okay, by the way, we know that there's a 6 on here and not a 1, if that's helpful. But this black dot calls out to me because there are only 2 groupings that can go on a black dot. You can either do the, let's just use this because it's not hit by anything. You can do the 1, 2, 4 grouping where you start with 1 and double it to 2, or you start with 2 and double it to 4, which always involves the 2. Or you can do the 3, 6 grouping. And that's it. You can't do 4, 8 because 8's not in the puzzle. So if you think about what is the smaller digit on my black dot, if the smaller digit's a 1, we can do a 2 next to it. If the smaller digit's a 2, we can do the 4 next to it. If we did a 1 next to it, it wouldn't be the smaller digit, right? So we're talking about what is, there will be one digit that is smaller than the other. If that smaller digit's a 2, then the bigger one's 4. And if the smaller digit's a 3, the bigger one's a 6. The smaller one can't be a 4 because then it would have to double to 8. And so as a result, if we don't have a 2, we can't do the 1, 2, and we can't do the 2, 4. So the only option is the 3, 6. And so this is a 3, 6, and that leaves behind a 4, 5 over here. And so that means that we can just fill 1, 4, 5 up here, and we can fill 3, 6 up here. Right. This is 4 length. So again, it can be missing basically 1, 2, 5, 6, 2 of those. But it can't be missing just the 2, 5, obviously. Maybe not so obviously, but it can't be missing just the 2, 5. This is missing the 2. In order for this to miss the 2, there was so much follow-up on this. Let's just keep following up on this too. Remember, the only options were we could do 1, 2, 3, 4, 2, 3, 4, 5, and 3, 4, 5, 6. So again, in order to lop off the 2, we had to first lop off the 1. So the only option that's left is to do the 1, 2. Sorry, the only option that's left is to do the 3, 4, 5, 6, which lopped off the 1 and the 2. So this can't actually be the 1, and in fact, the 1 ends up here. So the thing that looks like a 1 doesn't have a 1 on it, which is kind of amusing. And again, we can do a little bit of logic here because this isn't 1 or 2. So if it is the smaller digit, it has to be a 3, and that would be a 6. It could also be the larger digit. So we could do the 4, 2, or we could do the 6, 3. All right. 1 and 2 go in this box somewhere. Let's see, what else can we do here? So again, we can just repeat that logic here. We cannot be missing a 3 from this Renban. And so this cannot be the 3. This has to be 6, and that's 3. So that's not a 3, meaning that's not a 6. We know this is 3, 4, 5, 6, but I don't know what to do with that yet. We're missing the 6, so we could be missing the 1 or the 5 up here, but we can't be missing the 1 up here. So we have to be missing the 5. We've lopped off the 5 and the 6 from our chain. So that's not a 5, and that does not do anything yet. So these are 1, 2, 3, 4. This is not the 1, so it's 2, 3, 4. This is not a 5 anymore, so it is 3, 4, 6. I'm sure that's not what we need to do. All right. Now this, again, can be missing the 1, 2, 5, 6. Anything about this? Let's see. We have this. Basically, we have this black dot, and we have this, and we have Sudoku if there's any. The one's down here. The 5 is anywhere down here. I don't know if that's helpful. Does it have to do with this cell here, or is there more geometry we can do? Okay, well, one thing I can do, I can color this cell and this cell, green and purple. And the question that I want to ask is, where do green and purple go in this box? Because they can't repeat in the column, and they can't repeat on the Renban. And so there's only 2 cells left for green and purple, and so this is a green-purple pair, whatever it is. Now, we also know that these 2 digits here, let's just call them orange and blue. Where do orange and blue go in this column? Actually, is that the question I want to ask? No, I was thinking about that wrong, I think. Okay, never mind about that. I was just thinking, wait, we could call this an orange-blue pair if we wanted to, but we don't actually know where it goes in this box, so never mind on that. I don't know that this... I mean, I guess it means that these aren't green. And these aren't green because that's in the column. So green's one of these two. And then similarly, the purple is one of these two. So we actually know that purple is from 3, 4, 5, 6 only. Ah, so purple can't be 1. Okay, so that's the deduction. That's interesting. Okay. Some more clever geometry from Riffclown. So we said this is purple. We said it had to go over here, which means these can't be purple, which means that you can just see directly. That means purple's not 1 or 2. Right? If purple's in one of these two for the box, because it has to be. It's not here. It doesn't repeat on the Renban line. So it has to go over here in the box, which means it can't be the 1 or 2 because that would repeat a 1 or 2 in the column. So this is not a 1, and that places the 1 here. And that means there's a 1 in one of these two. Now, if this is a 1, that would be a 2, which would place a 2 up here. So what we've learned actually is that this Renban doesn't have a 1 on it, which means it does actually have a 5 on it. It can only be missing the 2 or the 6 along with that 1. I bet there's more I can do with this. Is there anything I learned about green? Well, we know green is 3 or 6, so this is not, oopsie. This is not green. This is our green, and it's a 3 or a 6. And that makes a 3-6 pair in here. And so the rest of this column is 2, 4, 5. Now this can't be a 5 because a 5 on a black dot just doesn't work. If you remember, I said it could be from the 1, 2, 4 group or the 3, 6 group. 5, we'd have to half to 2.5, which doesn't work, or double to 10, which definitely doesn't work. So this is down to 2, 4 only. Now, I don't know how much that helps, but I guess the 2 could be with a 1 or a 4, and the 4 would have to be with a 2. So yeah, we're in the 1, 2, 4 group. So this isn't a 5 either, and these aren't 3, 6. None of these are 3, 6. So the 3, 6, we know that one of these greens is 3, 6. And I suppose what we're saying is that the purple is either 4, 5 or 3, 6. I don't know what to do with that. Yeah, purple is 3, 4, 5, 6. I guess it's just not a 2. Oh, and that's actually important that purple's not a 2. Remember, we can use the same logic. Purple's not 1 or 2. And so where does the 2 go in this box? Because it's not where purple is and it's not where green is. And so this is where the 2 goes. So this is not actually a 2, meaning this can't be a 4. This has to be the 2. So we know there's a 2 on here, which means there cannot be a 6 on here. We already know it's missing the 1. We cannot place a 1 on here. And it does have a 2 on it. So the only digit it can be missing to preserve our sequence basically is it has to be 2, 3, 4, 5. So it has to be missing the 6. So that means that green is 3. That makes that a 6. And this can't be a 6. So actually purple is not 6. We've learned that because purple's on the Renban. And so purple is this 4, 5. So these are from 3 and then whatever the purple is, 4, 5. 3, 4, 5 triple. So that's our 1. And this is a 6. Okay. Makes that 2, 4. That makes that a 5. All right. Over here we get now the 5, 3, and 4. And so that means that this can't be the 5. This is our 4. All right. And that's a 4 and that's a 5. And now I don't need the colors anymore because they have digits. That's not 4. That's not 4. All right. This is the place for 5 in the box. This is where 6 goes. And this is 4 for the row. Gives us the 1 and the 4 here. I think it's just Sudoku now. We get the 1 here. These are from 3, 5, 6. This can't be the 5 or the 6. This is 3. This is 2. And then this can't be the 5. So that's 6. That's 5. We get the 3. This digit's the 6. And we're done. Neat puzzle, Riffclown. I liked the logic of this line. Took a bit to think about. And then really had to follow up on the consequences there. But I think the key deduction was that this could not be the 2. Because we proved that purple was here, meaning it couldn't be 1 or 2. So these 2 digits not being the 1 or 2 was extremely important to notice and then follow up on. That was neat. All right. Well, let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.